According to the National Electrical Code, specifically the 2023 edition, there is a requirement concerning the installation of branch circuits to server racks within an information technology room when these circuits are routed beneath an access floor. Article 645.5 Burn directly addresses this scenario. This section stipulates that within raised floor areas, all cables that are installed under access floors must be installed within approved raceways. The crucial aspect of this requirement lies in the phrase approved raceways. This means that simply laying cables directly on the subfloor is not compliant with the NEC. The term raceway refers to an enclosed channel designed to hold and protect electrical wires and cables. Examples of approved raceways include, but are not limited to, electrical metallic tubing, commonly known as EMT, rigid metal conduit, or RMC, intermediate metal conduit, or IMC, flexible metal conduit, or FMC, liquid-type flexible metal conduit, or LFMC, and cable trays. Cable trays are specifically designed to support and route cables, and they are often used in IT rooms and data centers because they can accommodate a large number of cables and allow for easy access and modification. The purpose of requiring raceways in this environment is multifaceted. Firstly, it provides physical protection for the cables. Access floors are often subject to foot traffic, equipment movement, and other activities that could potentially damage cables that are simply laid on the subfloor. Raceway systems shield the cables from physical damage, reducing the risk of electrical hazards and service interruptions. Secondly, raceways provide a degree of fire protection. In the event of a fire, raceways can help to contain the flames and prevent them from spreading rapidly through the cable infrastructure. This is particularly important in IT rooms, which typically contain a high concentration of electronic equipment that can be sensitive to heat and smoke. Thirdly, raceways facilitate cable management. By organizing cables within raceways, it becomes easier to identify, trace, and modify circuits. This simplifies maintenance and troubleshooting, and it reduces the risk of accidental disconnection or damage to cables. The NEC requirement to install branch circuits to server racks and cable tray when routed below an access floor is directly related to the overall safety and functionality of the IT room's electrical system. Failure to comply with this requirement can result in several negative consequences. One potential consequence is an increased risk of electrical shock. If cables are damaged or improperly installed, they can create a shock hazard for personnel working in the IT room. This risk is particularly acute in environments where there is a high degree of moisture or humidity. Another potential consequence is an increased risk of fire. Damaged or overloaded cables can overheat and ignite nearby materials, leading to a fire. In addition, improperly installed cables can create a pathway for fire to spread more rapidly through the building. A further consequence of non-compliance is the potential for equipment damage. Electrical surges or other anomalies can damage sensitive electronic equipment if the wiring is not properly protected. This can result in costly repairs and downtime. Beyond the immediate safety and functional concerns, non-compliance with NEC requirements can also lead to legal and financial penalties. Electrical inspections are typically required for new installations and renovations, and failure to meet code requirements can result in fines, delays, and the need for costly rework. In summary, the NEC requirement to install branch circuits to server racks in cable tray when routed below an access floor is not merely a suggestion. It is a mandatory safety measure. Compliance with this requirement is essential to protect personnel, prevent fires, safeguard equipment, and avoid legal and financial penalties. When designing and installing electrical systems in IT rooms, it is crucial to consult the NEC and other applicable codes and standards to ensure that all requirements are met. The specifics of cable tray installation are also important to consider. The cable tray must be properly supported and grounded. The support should be spaced according to the manufacturer's specifications and the weight of the cables being supported. Grounding is essential to prevent electrical shock and to provide a path for fault current to flow back to the source in the event of a ground fault. The cables must be properly secured to the cable tray. This can be done using cable ties, straps, or other approved methods. The cable should be arranged in a neat and orderly manner to facilitate airflow and prevent overheating. The cable tray must be accessible for inspection and maintenance. This means that there should be adequate clearance around the cable tray to allow for personnel to work safely. The cable tray should also be located in an area that is free from obstructions. It's important to note that the NEC provides specific guidelines for the types of cables that are permitted to be installed in cable trays. In general, cables that are approved for use in raceways are also permitted to be installed in cable trays. However, there are some exceptions. For example, certain types of cables that are not resistant to moisture or sunlight may not be permitted to be installed in cable trays that are exposed to these elements. It is also important to consider the ampacity of the cables being installed in the cable tray. The ampacity of a cable is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that specify the ampacity of various types of cables under different conditions. When installing cables in a cable tray, it is important to ensure that the ampacity of the cables is sufficient to handle the expected load. Another important consideration is the bonding of the cable tray. Bonding refers to the electrical connection of the cable tray to ground. Bonding is essential to prevent electrical shock and to provide a path for fault current to flow back to the source in the event of a ground fault. The NEC provides specific guidelines for the bonding of cable trays. These guidelines specify the size and type of bonding conductors that are required, as well as the methods for connecting the bonding conductors to the cable tray and to ground. Furthermore, consider the full rate of the cable tray. While cable trays are designed to hold numerous cables, there are limitations to how many cables you can safely and effectively place in them. Overfilling a cable tray can lead to several problems, including restricted airflow, increased heat buildup, and difficulty in accessing and maintaining the cables. The NEC doesn't explicitly specify a maximum fill rate for cable trays in all situations. Instead, it focuses on ensuring that the cables are installed in a manner that does not compromise their performance or safety. Firstly, proper spacing and arrangement are crucial. Cables should be arranged in the tray to allow for adequate airflow around them. This helps to dissipate heat and prevent the cables from overheating. Secondly, the weight load should be considered. Cable trays are designed to support a certain amount of weight. Exceeding this weight limit can cause the tray to sag or collapse, potentially damaging the cables and creating a safety hazard. Thirdly, accessibility is important. The cables in the tray should be accessible for inspection, maintenance, and future modifications. Overfilling the tray can make it difficult to access the cables, which can increase the time and cost of these tasks. Fourthly, adherence to manufacturer's specifications is essential. The manufacturer of the cable tray will provide guidelines for the maximum number of cables that can be installed in the tray, as well as any other relevant installation instructions. The NEC emphasizes the importance of following these instructions. Lastly, good engineering practices are key. Ultimately, the decision of how many cables to install in a cable tray should be based on sound engineering judgment. Factors such as the type of cables, the ambient temperature, and the expected load should all be taken into consideration. Article 392 of the NEC covers cable trays. It provides requirements for the installation, support, and grounding of cable trays. It also specifies the types of cables that are permitted to be installed in cable trays. Consulting with a qualified electrical engineer or contractor is highly recommended when designing and installing electrical systems in IT rooms. These professionals have the knowledge and experience to ensure that all NEC requirements are met and that the system is safe, reliable, and efficient. In addition to the NEC, there may be other applicable codes and standards that should be considered. For example, some local jurisdictions may have their own electrical codes that are more stringent than the NEC. It is also important to be aware of any applicable industry standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, or the Telecommunications Industry Association, or TIE. Remember that this is a general overview and specific applications may require more detailed analysis and consideration of other factors. Always consult with qualified professionals for specific projects. When in doubt about any electrical installation requirement, always err on the side of safety and consult with a qualified electrician or electrical engineer. They can provide expert guidance and ensure that the installation meets all applicable codes and standards. Furthermore, it is essential to stay up to date with the latest revisions of the NEC. The NEC is updated every 3 years, and each new edition may contain significant changes that affect electrical installations. Subscribing to electrical industry publications and attending continuing education courses can help to stay informed about the latest developments in electrical codes and standards. In conclusion, installing branch circuits to server racks in cable tray when routed below an access floor is an NEC requirement, not merely a suggestion. This requirement is essential for protecting personnel, preventing fires, safeguarding equipment, and avoiding legal and financial penalties. By understanding and complying with this requirement, you can ensure that your IT room's electrical system is safe, reliable, and efficient.